Hi, I'm Liz Sneddon. Let's have a look at the answer to question 3b. So here is our question, and you can see I've just copied down the bottom the diagram that we did in part A, and we'll need to modify that for this question. So the question talks about this bicycle ride, and it's talking about going from Ashburton through to Timaru and then through to Waimate. So we're now adding on some new information. We've got some new information about Waimate. So Nancy's grandfather says the chance that it's dry in all three towns on the same day is somewhere between 30 and 35%. Okay. And we're told on the day of Nancy's ride, it's dry in both Ashburton and Timaru. And we need to find the probability. So before I get into those details, I'm just going to start thinking about these three towns. So remember, our first layer was for Ashburton. The second layer was for Timaru. So we need to now add a third layer for Waimate. And we can add now the weather in Waimate could be either wet or dry. So we're adding on another layer here. Okay. So wet, dry. Oh, wet and dry. So that would what would normally look like the full three layers added. However, we've just got to remember we're told it's dry in both Ashburton and Timaru. So in actual fact, we just need to add on this piece down the bottom here. Okay, because we know it's dry in Ashburton, dry in Timaru, and so we're only adding on that third layer down the bottom. Okay, and so that's our structure. Now I've got to think about that 30 and 35%. And that talks about the probability of dry in all three towns. So that's saying Ashburton and Timaru and Waimate. So when we're talking about that probability, I'm not talking about the probability on the branches anymore. That's referring to a probability at the end here. Okay, so this is talking about the probability of being dry in Ashburton, dry in Timaru, and dry in Waimate. So that probability has to be somewhere between 30 and 35%. Okay, so I'm going to start by dealing with it if it's 30%. Okay, so I'm going to start and I'm going to look at both ranges. I'm going to look at what happens when it's 30%, what happens when it's 35%, and see what I can work out. So here's my diagram, and what I've done is I've put this probability here for being dry in Waimate. We don't know what that is, so I'm calling that P for probability. And I know the probability of being wet and dry, these two need to add up to 1. So if say one was 40%, the other would be 60%. So I'm going to call that P and 1 minus P. And remember what we said? We said that the probability of being dry in Ashburton, dry in Timaru, and dry in Waimate, I'm going to start with that probability being 30% or 0.3. So how would I normally work that out? Well, what I would normally do is I would do the branches. I'd say this branch, dry in Ashburton, times dry in Timaru, times the dry in Waimate, has to equal dry, dry, dry. So that means this probability is equal to 0.55 times 0.88 times that probability P that we don't yet know. But I can say, well, I know the total probability is 0.3. So what I can do now is I can actually simplify and rearrange and solve to find what the value of P will be. So that's what I want to do. So I am just going to grab my calculator first to do a little simplifying. And I'm just going to tidy up that right hand side. So 0.55 times 0.88 gives me 0.484. So I'm just going to make this 0.484 times P is equal to 0.3. Okay, so now what I want to do is I want to get the P by itself. So I want to take this to the other side of the equation. The opposite of multiplying is to divide. So I'm going to get 0.3 divided by 0.484 is equal to P. So I can now put that into my trusty calculator, and I'm going to get 0.3 divided by 0.484 gives me 0.6198. to 4 decimal places. So this is what happens if the probability is equal to 0.3. That would mean that this probability here, the probability that it's dry in Waimate, that probability would be 0.6198. So what I want to do now is I want to try and say, well, what if that probability, instead of being 30%, what if it was 35%? Because those are our two limits that we were given. So let's try that process again, checking if it was equal to 35%. So I'm going to say if the probability of dry is equal to 35%. Then remember what we did. We said that to find that probability we would do this times this times this. So that is going to form my equation. So I can say 0.35 has to be equal to 0.55 times 0.88 times P. So again, that 0.55 times 0.88, when we do that on our calculator, and I've forgotten what it was, so 0.55 times 0.88 is 0.484. So I can say that is 0.484 times P must be equal to 35%. So now I want to remove this because I'm trying to solve and get P by itself. So I'm going to say 0.35 divided by 0.484 is equal to P. And then I'm going to put that into my calculator. And I'm going to get 0.35 divided by 0.484 gives me 0.7231. Oh. Okay, so there are the two possibilities. If the probability is equal to 35%, then that would give us a probability of being dry in Waimate of 0.7231. However, if the probability was equal to 30%, that would give us a probability of being dry in Waimate of 0.6198. So I'm just going to write these two down. So if probability of dry is 30%, that means that the probability of being dry in Waimate would be 0.6198. And if it was equal to 35%, then that probability was 0.72, I can't remember what the number was, 7231. Okay, so now let me go back to the question. And the question says, if Nancy's grandfather is correct, what is the smallest probability that it is a wet day in Waimate? Okay, so the smallest probability of being wet is the same. If I go back to my tree diagram here, that's talking about the smallest probability of this 1 minus p. Okay, because we're talking about the chance of it being wet in Waimate. So we need to find 1 minus p, but we want that to be the smallest. Okay, so we want the wet in Waimate. In fact, the probability of it being wet in Waimate, that to be the smallest. So that's my 1 minus p, and I want that to be the smallest. And in order for that to be the smallest, we're going to choose the biggest value of p. So we're going to choose this value here of 0.7231. So the greatest chance of being dry, the opposite of that is the smallest chance of being wet. So I'm going to say 1 minus 0.7231, and that will give us a probability of let me just grab my eraser. I've just added a 0 in there that we don't need. Okay. So that is going to be 0.2769. So that is our probability. So in order to do the marking for this, if you are able to find either the value of 0.7231 or the value of 0.6198, then, or if you found this value here, that would get you an achieved U. If you found this value down here, the 0.7231, that would get you a merit. If you're able to go on and find this value here of 0.2769, then that gets you your excellence. But remember, you must have the working and the reasoning with it. If you just gave me the answer, you wouldn't get that excellence. Thanks for watching.